So I am helping you to solve problems step by step, thinking step by step. I'm not rushing to the problem. I'm helping you understand the problem. Okay. I can easily write the solution in 1 minute, but that's not the procedure. My procedure is to help you think. Chinta's procedure is to help you think. Okay, step by step, so that you can produce it, reproduce it in the long term.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMIMS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned.
So we'll be discussing 2024 JAM question number 3. Okay. So let's see what it is asked here. So you have a matrix A with the elements A, C, D, and 0, as you can see. And you're given is AD equal to 1 and C is not equal to 0, right? AD comes up naturally in a matrix, 2 cross 2 matrix, as you can see on the screen. The term AD. It can have other terms, but the term AD comes up.
Determinant.
Very good, determinant. And you can also see that C and 0 are here. And so therefore, this condition translates to the fact that the determinant of A is equal to AD minus C times 0, that is 0, is equal to, and AD is equal to 1, it's 1. Did you understand, all of you? Yes or no? Good. So this condition tells you, the first condition tells you that the determinant of the matrix is 1. What does the next condition, what can we know from the next condition? So we are going to do it step by step, one by one. So let's think about it. We are given the information of A inverse and adjoint of A inverse, right? Now tell me one thing very carefully. One thing very, very carefully. That, do you know a relationship between adjoint and A? Anyone? So first, this gives an idea about determinant, right? Determinant is equal to 1. But the second set of condition, the information, what does it, so you have to understand what information does it contain, right? So, and it has two aspects, A inverse and adjoint of A inverse. Rather, A, so essentially it asks you that there is some relationship, or there is something to note, something to understand between A and adjoint of A. So now I will ask people out here that what relationship do you know about A and adjoint of A? A inverse is equal to adjoint of A by determinant of A. So you can see that this makes sense now, right? Why? So this makes sense now because, yes, you're already given information about determinant of A. So that means that this turns out to be 1, and we get A inverse is equal to adjoint of A. Okay, so you've got, so the first information, the first statement gives an idea about what is the value of the determinant. And the second information gives you an idea about some relationship, like it invokes the idea of, to implement the idea of A, the relationship A and adjoint of A. And we know that the relationship here is the following. Like, it's general, not here. That A inverse is equal to adjoint of A. So now let's put that back into the equation. So what do we get? So let's make it a bit clear. All of them. So we have got number 1, determinant of A is equal to 1. The second, we know that A inverse is equal to adjoint of A divided by determinant of A, which is nothing but adjoint of A here, because determinant of A is equal to 1. So what does it imply? It also implies, therefore, adjoint of A inverse is equal to A, right? That means adjoint of A and A are inverses of each other. Adjoint of A and A are inverse of each other, right? So therefore, let's replace this adjoint of A inverse here. What do we get? A, right? Because, and why did we do that? Because understand that the question is asking you, so this is something you have to do it very fast in the future, but you have to understand and do it at a very slow pace. So you have to walk first before you run, right? So understand that you have to find the relationship between like alpha, beta, gamma, and delta and the A. So it will be great if you can just convert everything in terms of A. Yeah, adjoint of A is related to, of course, A, but you know A inverse, right? Also same thing here. Let's talk about it now. So so therefore adjoint of A inverse is A, and you're given that A plus A inverse is equal to this quantity. So essentially you have to find out the value of the matrix A plus A inverse in terms of A. Okay. Now this is quite easy because A is a 2 cross 2 matrix, and there is a specific way to find out the inverse of a 2 cross 2 matrix, right? So let me show it to you. And again, you can use the same thing as a joint of A. A inverse is nothing but adjoint of A. So therefore, you can write it as adjoint of A. Because inverse is very hard to find. Adjoint operation is just replacement of certain quantities, right? But inverse is very hard to find. So that's why what we are doing is that we are transforming the equation into a more tractable format. So this is adjoint of A, and this is A, and this is given to be this. So therefore, you have to find out the adjoint of A and A. All of you got it till this point of time? A is already given. So now there's a emoji out here. You can see like this. Yeah, great. Probably there's an emoji button out there just beside in the middle of the meet. Okay, so let's now find out adjoint of A. Adjoint of A is very easy because you have A, 0, C, and D. So what happens? This terms get replaced out here. So it is going D and it becomes A, and this becomes minus C. Like this becomes minus of 0 and this becomes minus of C, right? So essentially, this off diagonal terms becomes minus of each other and the diagonal terms get replaced. Okay, so therefore let's write it down clearly. Adjoint of A is equal to therefore A, B minus C and 0. Sorry, D, A minus C and 0. Okay, and therefore you have to add them up now. So A plus adjoint of A will become what? You can see that A plus D, 0, 0, and then D here. A plus D again here because yeah, because it just got replaced. So the answer is this, right? Alpha is equal to A plus D, beta and gamma will be 0, and delta will equal to A plus D. Now I have a follow-up question for you. Okay. The follow-up question is that, is this relationship really needed? What happens if determinant of A is not equal to 1? What will happen? Let's see. Let's see the general term without, let's say determinant of A is equal to lambda. Okay. Then what happens in a general case? Because it can come as a different question, right? We should always think about, when we solve a question, I think a student should always think about creating their own question, right? That will help them to understand the perspective of the question maker. Okay, also it will help you, it will help you a lot. Okay, I'm telling you, in this age of chat GPT and all these things, if you just do this exercise and forget about everything else, forget about timed quizzes and everything, just do this stuff, your understanding of the whole subject will increase manifold. Okay, so let's see what happens if A, determinant of A is lambda. So again, A inverse is nothing but adjoint of A divided by lambda. You know that lambda, of course, is not equal to 0. Let's say. So we have, therefore, here A inverse will be adjoint of A, and A will be like adjoint of A inverse will be what now? Adjoint of A inverse will be now let's take lambda on the other side. It will be again A inverse by lambda. Do you agree? So let's see, how do you find the adjoint of A inverse? So I skipped a step. Let me show it to you. So you take this lambda on the other hand side. So it becomes this. Now you do adjoint inverse now. Therefore, you have to do the inverse of this. How do you do the inverse of this, guys? How do you do the inverse of a constant time matrix? So this is the idea. But if you multiply this to this, it's not coming out to be I, right? So this is not it. Even if a constant is there, it should be by, because constant is nothing but a 1 cross 1 matrix, right? So AB inverse is nothing but B inverse A inverse, right? So even if A is equal to lambda, that's a 1 cross 1 matrix, it will be lambda inverse, right? Got it, guys? It will be B inverse by A, lambda. So therefore, it will be this, right? So we have got now A inverse plus adjoint of A inverse is nothing but adjoint of A by lambda plus, adjoint of A times lambda. Did I do wrong? No. Adjoint of A by lambda and adjoint of A inverse is A by lambda. So it's nothing but adjoint of A plus A by lambda. And if you do adjoint of A here, let's do adjoint of A, even if it's a general A, B, C, D. This is A, the adjoint of A will be what? DA minus B minus C, right? So even if you do here, this turns out to be what? B cancels if you add them up. So it's again A plus D times a diagonal matrix. So it's like A plus D times I. So this is the general result is equal to I, means because if you add it, it will be all A plus D in the diagonal, right? If you add it, it will be A plus D in the diagonal and 0, 0 here. So it will be A plus D times I, right? And therefore A plus D comes out and there's a lambda divided by this, right? So you can see that the result that it will be A plus D 0, A plus D, this will actually be holding also in general case. But just because lambda is equal to 1 here, determinant is equal to 1 here, it just holds that way. So in general, if determinant was not given equal to 1, it will be essentially, let's say determinant was given equal to 2 or 5. It will be 5A plus D and 5A plus D. Sorry. A plus D by 5 and A plus D by 5. Okay. So essentially it's A plus D divided by determinant. All of you understood this, guys? Yes or no?